Clark, Director of Autonomous Driving and Safety Technology. In the last tutorial, we discussed adopting Innolot, a high reliability solder alloy specifically for advanced safety systems. Today we will look further into that material and discuss systems and designs that will benefit and may be able to achieve greater reliability by using additional materials in the stack. As consumers, we have high expectations for vehicle design and the overall travel experience. Electric systems are the greatest growth segment in automotive. This is a result of increased number of advanced safety systems and the incorporation of an electric powertrain. Car makers are innovating in areas they never expected. Much of that technology is driven by the consumer experience and technology that we are accustomed to from our daily lives. These systems are enabled through electronics originally designed for more benign applications, but we must prepare and succeed in the harsh automotive environments. As we shift responsibility away from the driver to a machine or vehicle, car makers are putting more stringent reliability requirements on the advanced safety systems. It is understandable, but it is not clear whether the requirements are currently achievable. It may be necessary to combine multiple material sets. We easily understand the need for Innolot in near engine and under hood applications. The location is very hot, even with protective housing. A look inside the box shows some delicate icy substrates executing the work of the engine control unit. Innolot also helps resist the frequent vibration experienced through engine function and constant feedback from the road. When we think about the placement of advanced safety features and their electronic hardware, it might not seem as harsh as an engine. In most instances, that is true. A camera by the trunk or on the side mirrors does not see pollutants that are experienced near the engine, but heat and thermal cycling are still very much a concern. We've all been warned about how quickly a car interior can get hot. If you couple that environmental heat with the heat of a processor constantly in function, high reliability enhanced materials become a necessity. We know the system location is important, but now the bigger concern is constant function of a critical IC substrate package. The systems required for semi-autonomous and fully autonomous driving require high processing power. These packages are functioning for extended period of time, much more than their consumer applications. So if we think about a rideshare scenario, the sensors will be running always. The packages were not originally designed for this level of use. Automotive engineers are required to build more robust systems. If we think about cameras in our daily life, most cameras we know take a single picture from your phone, maybe a short video. Surveillance cameras are stationary, normally in covered environments, so the expectations and the environments of automotive are much more demanding. This is where Innolot becomes a necessity as discussed in our previous tutorial. And now when we consider large BGA packages that have safety critical applications, it can also be a time for reinforcement. Still, design, package size, pitch, and performance expectations will play a significant role. Advanced safety and the path to full autonomy require a collection of systems working together. Processing occurs at each sensor, and then for multiple sensors, and eventually information will reach a central computer which makes a calculated decision on next steps to keep the occupants and the environment around the vehicle safe. This requires intricate IC substrate packages. Many will be ball grid arrays with narrow pitch and high pin count to execute the required calculating and processing. These packages especially can benefit from the Innolot alloy, but also the reinforcement of an epoxy adhesive. Some assemblers are concerned about the use of an underfill. It requires additional processing steps in assembly after reflow, including a separate curing stage. There is also concern regarding getting the material fully under the package, completely cured, and reducing voiding in that epoxy. And of course, cost is a consideration. Corner bonding or edge bonding is a great solution. Bonding material is dispensed prior to the component placement, but it will prevent bow and twist. The material cures during the reflow process. It delivers reliability to the large packages. It can be applied to the corners or further along the package edges as an edge bond. Depending on your process flow, it can be applied before or after package placement. Alpha High-Tech Edge Bond technology is a single component heat curable epoxy that delivers a strengthened connection between the component and circuit board. It enables resistance to more stringent reliability tests. In this body of work, IPC 9701A thermal cycle testing was executed to understand the comparison of no reinforcement or simply the solder alloy versus the use of an edge bond adhesive, specifically for BGA packages. Measurements were taken at 1,000, 2,000, 2,500, and 3,000 cycles to match car maker requirements. 2 BGAs which varied in pitch, size, and IO count were tested. The first was a 17mm by 17mm PBGA with 256 connections at a 1.0mm pitch. The second, a 12mm by 12mm CTBGA with 228 connections at a 0.5mm pitch. We also tested the material as a dot in the corner as a corner bond or further along the edges as an edge bond. After 1,000 cycles, none of the candidates display failures. The solder paste alone and the use of the adhesive all pass. At 2,000 cycles, the solder alloy begins to show failures on the smaller device. 50% of the solder joints display resistance failures. Use of the reinforcement maintains passing results. At 2,500 cycles, the 228 package with 0.5mm pitch shows an even greater percentage of resistance failures when it is not reinforced. This is likely due to the stress caused by the package design and CTE mismatch with the printed circuit board. The corner bond and edge bond help to eliminate these differences. The Innolot alone samples were removed from the test at this point solely for the 228 package. The corner bond and edge bond continue to deliver no resistance failures on the over 36,000 connections tested. For the other package, we begin to see a low level of failures on this wider pitch device for the corner bond only. The PBGA 256 with Innolot only and edge bond performed very well at 2,500 cycles. So attention needs to be paid to package size, pitch, and overall BGA design, including die to package ratio when considering the addition of the adhesive. Finally, at 3,000 cycles, there are no additional failures in either package style. The edge bond proves to be a valuable reinforcement for both package types in this testing. If you have a need for enhanced reliability, whether with SAC or a high reliability alloy, these added adhesives are a great alternative to underfills. So maybe the full support of an underfill is not needed. Bond the edges and enjoy the benefits of a reinforced connection. Transitioning responsibility away from a driver to a vehicle puts greater importance on the reliability of the safety systems. Constant use of these electronics creates more thermal and mechanical strain. The use of enhanced materials may be a necessity for your design, and in some instances, combining materials to deliver even greater reliability will achieve car maker requirements. Did you know that edge bond is currently being qualified by both car makers and leading system suppliers? These applications include the coordination of communication between multiple systems. To make advances in your technology, you will need advanced materials that match your expectations. We have over 60 years experience in all market segments. We specialize in material development, and as a leading global supplier, we take pride in having a complete understanding of the automotive market's expectations with a strong focus on reliability. I want to thank you for your time, and I look forward to continuing this discussion with you.